So hopefully you're happy drawing tree diagrams with replacement. We're now going to look at when there isn't replacement and dependent events. So this question is exactly the same as the first example we did on the previous video, apart from one small difference. So we've still got there are 4 yellow and 5 red balls in a bag. A ball is picked, but here it says not replaced. So that word makes a massive difference to the whole question. The actual structure of the tree diagram is going to be exactly the same, as in first pick, second pick, and the options that you can have, yellow and red balls. So looking at the bag, on your first pick, you've got 4 yellow and 5 red. So the probability of getting a yellow is 4 out of 9 in total, and the probability of getting red is 5 out of 9. So actually exactly the same as the first question we did. Okay, we're going to ignore the bottom section of the tree diagram for now. So we're only going to imagine if you've picked a yellow on your first pick. So this bag has 4 yellow balls and 5 red balls in. And first pick, you can pick any of those. So we know that the probability of picking a yellow is 4 out of 9. So you pick out the yellow ball, but this time you do not put it back in. So now when we take our second pick, there is no longer 9 balls in the bag. There are only 8 because we've already taken out a yellow one. Now we can do the probability of picking yellow and red. So now there are 3 yellow balls left in the bag because we've taken one out of 8 possible. So the probability of picking yellow on our second pick is now going to be 3 over 8. And for red, well, because we only picked a yellow ball out, there are still 5 red balls in the bag, but out of a possible 8. So the probability is going to be 5 over 8. Also, remember that branches add up to 1. So 3 over 8 plus 5 over 8 is going to give you 1. Now we've completed the top section of the tree diagram, we're going to ignore that and we're going to look at the bottom section. So now this is a completely different scenario. So imagine you have picked a red ball as your first pick. Again, because we've only taken 1 ball out of the bag, we've got 8 balls left in the bag because this is a completely different scenario. But this time we took a red ball. So there are still 4 yellow balls left in the bag, but now there are 4 red balls. So the probability of picking a yellow after picking a red is going to be 4 over 8. And the probability of picking a red after picking a red is going to be 4 over 8. So now we can look at the probability of a combination of these. The first one, what is the probability of picking a yellow and a yellow? Remember, it's yellow and yellow, so we multiply. So 4 over 9 multiplied by 3 over 8. We're now going to do the same for the probability of picking a yellow and a red. A red and a yellow. And picking red and red. Now we have a completed tree diagram, let's have a look at what questions we could be asked. So what is the probability of getting 2 red balls? So remember you multiply along the branches, so the probability of 2 red is going to be 20 over 72. What's the probability of getting 2 different? There's 2 options for this, so yellow and red or red and yellow. So you're now adding those 2 together. So 20 over 72, add 20 over 72. Denominators are the same, so we can just add the numerators to make 40 over 72. What is the probability of getting at least one yellow ball? There are 3 ways of getting at least one yellow, so yellow and yellow, yellow and red, red and yellow. So you can add these 3 probabilities together. The other way you can do this, and probably is quicker, is to find the probability of getting red and red, which is 20 over 72, and then subtract that from 1, and you'll get the same answer. So you'll still get 52 over 72. For the rest of this video, there's lots of past paper GCSE questions. I want you to have a go in your book and then play the video to see the solutions. Any problems, message me and we'll go through them.